Alrighty, folks, hello. Today we're going to start Unit 4. Unit 4 is all about the history of life on Earth. And earlier, you guys just watched a YouTube video on essentially the origin of life. And now there are some pretty big concepts that were talked about in that video. And there were some concepts that I don't even need you to really know or think about until much later in your academic careers. For example, all the stuff on physics, entropy, thermodynamics, uh, forget that. That part's really not important. The real important part is the history of how Earth forms and then the theories of how we get to life eventually. And we're not going to dive much deeper into that, but we are going to talk about how life develops and how we know that there was life before us. So it's going to be a fairly small unit just because it's all just evidence from the history of life on Earth. So we're really just going to talk about origins, um, not really origins of life, but really just more the beginning of life itself. So by the end of this lesson, you will be able to explain how fossil data can be used to provide evidence of the history of life on Earth. Now, after this video, the whole notes that we take from today will be posted onto Google Classroom. So if you miss anything, if I go too fast, you don't have to ask to pause the video because you can just go back yourself and fill in the notes there. And as always, if you have questions, see me tomorrow, email me, do whatever you need to do to get your questions answered. Also, after this lecture, you will have a worksheet to do. The worksheet is on Google Classroom as well. It's a Google form, 8 questions. You cannot, you cannot edit your response. So, and it is graded based on correctness, not for completion. Now, you can submit multiple forms. You can submit it again and again and again until you get a 100. So let's go ahead and get started. Fossils, remains or traces of once living organisms. This is kind of the big definition we need. Remains or traces of once living organisms. Now, I want you to really emphasize a few things here. One, the remains part, okay? Often when we think about fossils, we think about the big skeletons of dinosaurs or the big skeletons of some dead animal, and that would be the remains. However, we're also looking at traces of once living organisms, and we'll take a look at what that kind of means in a sense here in a second. But first, let's talk about how fossils form. It is absolutely rare for an organism's remains to actually form a fossil. This is because fossils don't necessarily have to form. There are so many factors that can affect the skeleton, the bones, any of those trace remains that can wipe away the fossil before it can even get to that preservation part. The remains of less than 1% of all species that have ever lived become fossils. They form most often when an organism's remains are quickly buried by sediments. So if you think to how the dinosaurs all went extinct, most popular theory is meteor hits the earth. Well, when that meteor hit the earth, all that dust and all that dirt got kicked up into the atmosphere. Anytime a volcano explodes, there's dust spewing into the atmosphere and ash. And if that buries a dinosaur, that means all those bones, as they decay, are buried under dust, ash, dirt, which then allows for very quick burying for organisms. Now, that doesn't even mean that those organisms are going to fossilize. It just means that they can fossilize. This is also why most fossils are found in sedimentary rocks. You probably haven't talked about rocks in a while. Remember, there are 3 types of rocks. Sedimentary rocks are the rocks that form layers. Okay, so when we see layers of rocks, we tend to see fossils. Um, Fossilization occurs fairly quickly in rivers, lakes, and oceans, which is why many water dwelling organisms are fossilized more than land organisms. Fossils from an organism's bones, teeth, shells, or movements. Um, we're going to see fossils of dinosaur footprints. We'll see fossils of teeth marks. We see shells all over the beach all the time. And then proteins and genetic materials may also fossilize. So the best way I can explain this is Jurassic Park. In Jurassic Park, they take the mosquito that was caught in the amber, and we'll talk about amber later, and they take out the blood from the mosquito, and then they get the DNA from the blood. Now, that's not really how any of this works, but that's kind of like the best way to think about it is blood or some kind of DNA traces from a prehistoric animal has been caught in some fossilization way. Sorry, real quick, we'll go back in a second. Proteins and genetic materials, we will cover more deeply next unit. We'll talk about, you've probably talked about DNA before, but we'll kind of get into it just a little bit more deeply. All right, there are many types of fossils. First one is pre-mineralized fossils. These are tissues that are replaced by minerals from water and form a 3D copy of the organism. There are many types of minerals in water. Calcium is a huge mineral in water, especially in this part of Nebraska. We have what's called hard water, and hard water just means that there are metals such as calcium or magnesium that's in our water, and it's very hard on the pipes. And so if you're ever in the shower or you're looking at your sink, you'll often see that white crust that forms around the faucet. That is calcium, and it's come out of the water. So really, these are just calcium deposits of remains that formed in the forms of remains of dead animals, essentially. All right, carbonized fossils. These form when an organism, usually a plant, is quickly buried and flattened by the pressure of sediments built up above it. Most of the nitrogen, oxygen, and hydrogen that made up the organism gets removed. So it seeps out of the sediment. Only the carbon remains as this thin black film. Carbon is the most abundant element on Earth. There's lots of carbon, and carbon makes up every living being. It makes up you, it makes up I, it makes up the grass outside, it makes up the trees, it makes up your dog, your cat. Carbon makes up everything. So it's very easy for these carbon remains to be left behind. Also, the reason why the carbon is black is because carbon in its most basic form, when it's not in a gas state, it's in the solid state, is black. So the graphite in your pencil is essentially a carbon deposit. It's a bunch of carbon atoms linked together. So this here is just solid carbon left behind. All right, another one is amber. Amber fossils are kind of like the Jurassic Park example from earlier. The organism gets stuck in sap. Over time, the sap hardens into the amber. The organism gets preserved in the amber. So, as you can see here, we have this tiny ant that is stored in this, what looks like kind of a gemstone, but that's really just sap that is hardened. And you can break open that sap, and however, then the decay process for that animal would start. We often see bugs encased in amber because we'll see those bugs got trapped on a tree that was leaking sap, and then they got encased in the amber. We really don't see large organisms like a woolly mammoth or a T-Rex or anything like that getting encased in amber, because think about it, those things are huge. You would need so much amber. You would need as much amber that could fill up this entire room to encase the organism, then harden. So we are not going to see bones, as I should say, large bones entrapped in amber. We're really only going to see those bugs and those very tiny organisms. All right, cast and mold. Um, these are really common fossils that we see because these cast and molds often form in water. So, after an organism's tissues decompose, an impression of its body shape can be left in sediment. So, water can seep in and fill the impression. Minerals in the water form the cast fossil. So, this is just like earlier when I was talking about the calcium deposits. Um, this is the same thing. It's just now we have the cast and mold from the decomposition of tissues. So here we see a lot of prehistoric, basically water bugs. Um, yeah, and they're trapped in sand. You can also look a little bit here. We have some old, what look like starfish, right? So remember, fossils often occur in sedimentary rocks. A type of sediment is sand. Oceans, rivers, lakes all sit on top of sand. So when these water creatures die, they sink to the bottom of the ocean, they land in the sand, their tissues decompose into the sand, leaving an impression. That hard calcium and magnesium filled water fills that impression, and now we have these leftover fossils. All right, so the next type of fossils is the trace fossils. And this is what I was kind of talking about earlier when we were talking about the definition of a fossil being both remains or traces. So this trace fossil really just demonstrates evidence of some animal that lived there. And we get how old that animal is through a variety of methods that we'll talk about later on. A record of the activity of an organism is the bare definition of a trace fossil. These can be footprints, a burrow, scratches, or fossilized dung. Fossilized dung meaning poop. They are categorized by the activity that created them. So we would put all the footprints in the same category as scratches. I'm just pausing right now to give you guys a second to write that down. All right, now we'll move on. Again, if you don't get any of these notes, don't worry. The notes will be posted to Google Classroom. All right, the next type of fossil is fossils that come out of tar pits. So areas where asphalt seeps up to the Earth's surface. So when we hear the word tar or asphalt, we often think of roads. We think of those black strips that we fill in potholes or cracks in the street or whatever. That directly comes from this material out of the earth. And there are tar pits all over the earth. The most famous tar pit is in California, where we have pulled entire like saber-toothed tigers out of that tar pit. There are, I believe, if I'm not mistaken, there is a tar pit in Nebraska. Um, I believe so. Google it to make sure that I'm not losing my mind, but I believe there is. And I believe we've found some of our woolly mammoth carcasses from those tar pits, but I could be hallucinating right now. Who really knows? Google it, fact check me, tell me if I'm wrong. Um, where was I? Oh, yes. When an organism dies, tar covers the body. The tar dissolved the soft body parts, but preserves parts like exoskeletons and bones. So when we see large bone structures, some of those do come out of tar pits. Exoskeletons are basically bugs or water creatures that have hard outer shells. So, like crabs, those are exoskeletons. Many insects have exoskeletons. Forgive me for not giving better definitions of some of these. Um, Remember, at heart, I'm a chemist, not a biologist. Um, but this is a lot of biology. So I may I may get a few things a little twisted here and there, but don't worry, we'll always get it right in the end. All right, frozen remains. This is where we actually see entire carcasses preserved. Frozen remains form when an organism becomes trapped in some way, dies, and then is quickly frozen. If the surroundings stay frozen, the fossil will remain frozen. Freezing preserves much of the organism, including the genetic material. You can get DNA straight out of your skin cells, straight out of truly any cell. And a frozen remain, all those cells are preserved, and then you can get those cells and extract them and get the genetic material. So let's talk about a scenario of how frozen remains can actually happen. So it would be easy to think that simply during an ice age, woolly mammoth dies, gets covered in snow, boom, frozen remain. Not really quite how that would work, because that carcass is not going to freeze quickly enough. However, here is a scenario. Say there is a supervolcano, and the supervolcano goes off, dust fills the air, so does carbon dioxide, sun gets blackened out, temperatures would drop rapidly. It would rapidly shift Earth's climate to change it into an ice age like time. Many of the dinosaurs, or as this is a pachyderm, any of these creatures would get stuck under rubble. The Earth would quickly freeze, cool, all those temperatures break down, and now we have frozen creatures. Then those creatures just have to stay frozen in a climate that is cold nearly year round. So, Antarctica, the Arctic, the northern part of Siberia, which is in Russia, that is where we really see those frozen remains. We're not going to really see frozen remains in North America, because North America largely melts at some point or another. Unless you're in the way northern part of Canada, which nearly nobody lives there, you're really not going to see that in North America, certainly not in South America or Africa or Europe or Asia. Well, like I said, the very northern part of Asia, which is Siberia. So really think about this like Antarctica. This is where we see those frozen remains. All right, that wraps up notes today. We're going to pick up on the fossil record tomorrow, where we'll kind of dive into the fossils that we know of and kind of a timeline of these fossils. And we're going to talk about the geologic time scale. We're going to talk about all those different things that we all of the knowledge we've gathered because fossils exist. So it'll be a great start. Next up, you're going to watch a very short video just on fossils. It's like 4 minutes long from National Geographic. Just quickly about fossils to kind of wrap up what I just talked about. And then you'll have time to complete your worksheet today. So sit back, relax, enjoy this one last video. Make sure you get your homework turned in. I will see you tomorrow. Thank you very much. Again, sorry, one last time. Don't forget, the notes will be posted to Google Classroom. So if you missed anything, you can always ask a neighbor. But if your neighbor missed it too, don't worry. It'll be on Google Classroom. Thank you. I will see you tomorrow.